Hi, in this video we'll be talking about the problem 3 nights. So this problem was removed from the contest because the solutions was available out online and a lot of people were just blindly pasting the solution. So we had to remove this problem from the contest as the contest is a prized contest. However, since this problem is really nice if you think about it combinatorially, so I'll be making a video tutorial of it as well. So in this problem you are just given a 2n cross 2n chessboard and the 3 knights that you need to place should not attack each other. So now how many different configurations are there? So this is the whole problem. And the chessboard is given to be 500. Now in this problem this 500 actually allows you to use some n square and cube algorithm, but actually you can solve this in order 1 as well. So we'll be discussing the order 1 solution for this, how to get the direct formula for this one. Okay. So for this, for 4, there are just these 4 configurations possible. Okay, so let's have a look at the idea that how do you count such problems that you have to place 3 knights and this. So the biggest hint in this problem is this, it is given it's a chessboard. So how do you use this to your advantage? Let's look into that. Okay, so now notice that there is a very nice property on chessboard that, let's suppose there is a knight on a white square, okay, and there is a knight on a black square. Okay, now from a knight we know that if you are at some x comma y, you can do plus minus 2 comma plus minus 1 moves and plus minus 1 comma plus minus 2 moves, right? These are the possible moves that you can do from this chessboard. Now all of these moves actually have a Manhattan distance of 3, right? So you always shift by a Manhattan distance of 3, and we know that in the chessboard if you are at on a white square, this will be a black, this will be a white, and this will be a black, right? So whenever you go from this to this, you basically change the parity of your color. So if you are at white, if you are a knight which is placed at white, you can only attack black squares, and if you are a knight at black, you can only attack white squares, right? So white attacks black, black attacks white. Okay, this is the only possible configuration. Now you have 3 knights, right? Now we have to position 3 knights, so there can only be 4 possible ways, right? 0 white, 3 black, 1 white, 2 black, 2 white, 1 black, 3 white, 0 black, right? These are the 4 possible configurations. Now this and this is easy because there are 2n square number of board squares, and out of these, exactly these many board pieces are white and these many are black as well. Okay, since it's even given to you. Okay, now if these are the number of white squares or black squares, we know that if you place 3 knights in black squares, they won't attack each other because a black knight attacks a white square. So all of the 3 are in black, so that's not a problem. So if you just do a choose 3 of all these squares, you will get the number of ways over here, right? So this can be found out very easily over here, right? The answer for this would be same as this, right? And 2n square by 2 choose 3, right? So this you can find pretty easily. How do you find these 2 parts? Like you have 2 black and 1 white, so there would be some chances of attacking, right? So we would be enumerating on this one piece that is there, 1 white or 1 black, because we would be trying to check the number of positions that leads to some configuration by this 1 white, and once we place 1 white at that place, how many black squares get removed, and in rest of the black squares you can place at any 2 positions because they won't attack each other. Okay, so let's have a look at a chessboard. So in a chessboard there are some different kind of positions that can potentially happen. So let's say this square, okay, so this has 2 neighbors, right? This has this neighbor and this neighbor. Okay, let's talk about this square. This has 1 2 3 neighbors, right? This has, sorry, let's change the color. this has 1 2 3 4 neighbors, right? This 3 and this 3 would be same, so this would be green in color as well. Okay, let's talk about these central squares, okay, which have like sufficient amount of squares. So each of these will restrict 8 moves, right? Each of these will restrict exactly all the 8 neighbors that it has, right? Now let's talk about these cells. Each of these cells, let's talk about just one of them. Let's talk about this one. Okay, this one will have 1 2 3 4 5 6. This has 6. Okay, let's talk about this one. This has 1 2 3 4. This has 4. Okay, and in a chessboard you will see that, okay, so you have something like this. There would be one small square over here which is different, this 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 is different, and all of these will have same number of neighbors, and all of these will have like reduce the same number of black squares. So let's suppose we are placing one white knight. Okay, let's suppose we are talking about the configuration 1 white 2 blacks. Okay, the other one will be symmetrically the same because it's even and whites and blacks are exactly equal. Okay, so if you place the white knight over here, you now know that 2 of the positions have got removed. Okay, so there are 4 such positions, this, right? So from that you can place it over, like you can take 4 multiplied by, if you place over there the total number of black squares, you know, this many squares. Okay, so let's call that some variable b minus, there are 2 squares getting removed. Okay, so this would be the number of places that are there. Okay, sorry, this won't be closing over here, right? These many places are there. After you place one of the knights at these one of the 4 positions, b minus 2 positions will be left for the rest of the 2, and out of these b minus 2 you can choose any 2 because they won't attack each other, right? Similarly you can place at, so you can take a classes where this would be like one class, these 2 squares, because both of them will remove 3, this will remove 4, this will remove 4, this will remove 6, this will remove 8. So you can break the board into some of these pieces. So exactly there would be something like 1 2 types, 3 4 5 6, there will be 6 types of cells that can happen on a board, that can be present on a board. Okay, and with these 6 cells you have different number of black square getting removed, and you can just keep you can just on a notebook count the number of squares, like let's say this if this is an n 2n cross 2n chessboard, there are 2 removed, so this dimension would be 2n minus 4. So there are 2n minus 4 whole square number of board chess places where you have 8 number of blacks neighbors removed. So this would be multiplied with b minus 8 choose 2, right? So this is how you add for all the 6 different types of chess cells possible, chessboard squares that can lead to answers. So there was this 2 1 3 1 4 1 6 1 8 1, right? So if you count all of these, you will get the total number of ways that how many in all of these, if you place one white, how many blacks are left, you have that count b minus that many, and you can take choose 2. So you just need to keep a track of all these numbers. Like there would be there is n minus 4 2n minus 4 square number of cells like this. There is exactly 2n minus 4 times 4, 2n minus 4 times 4 number of such squares. Like there would be 2n minus 4 over here, 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 and all of them will get multiplied with b minus 4 choose 2, right? So something like this. So you can keep on adding all of these terms for all the 6 types of cells, and you can get the closed form expression for the number of ways you can place a knight. Okay, so this is also, there is another way you can do this, that just do a brute force and generate maybe first 5 or 6 terms, and you can notice that there is like if you extend the chessboard by one more side length, like let's say n was equal to some n and then you make it n plus 1, so you have a 2 length increase, right, in the chessboard. So in this increase there is only maybe some n square or n, there can only be n square or some order n cube number of increase in number of positions, right? There is some polynomial, some small polynomialic relation between the number of increase in the cells. So this can suggest you that okay, maybe the total number of possible ways can be a polynomial. So you can just brute force and generate for, let's say, 2 4 8 60 2 4 8. So you can generate for some values 6 10, like generate for 5 values and then just use a interpolation to get the expression for the number of ways, and it turns out it's a 4-degree polynomial. It's not 4-degree, it's 6-degree to be precise. So just just generate up to maybe 20 terms and just use the interpolation technique to get the polynomial for that, and you will get the correct polynomial, and you can use that to evaluate for any larger value as well. So this is also one of the potential solutions for this. Okay. But in this setting, when the board was like, if you just try to count it on a board with 3 pieces, it becomes difficult. But coloring it as a chessboard will give you some cases that okay, black cannot attack black and white cannot attack white, so that reduces the possibility a lot, and with that counting becomes really easy, right? Okay, so that's all for this problem. Thank you.